Okay, as I promised in the last class, my dear friends, I am going to bring the benzodiazepine. It is the next class of the sedative and hypnotics. Okay, the sedative hypnotic introduction, everything is over. I don't want to repeat once again. The next class is the benzodiazepines. See, for saving time, I wrote this table. Don't misunderstood me, because for the medicinal chemist teacher, writing structure on the board is very important. Nowadays, many of them, what they are doing, they are running the PowerPoint, that one, this one, they are not using the blackboard or chalk piece or any whiteboard marker. They are not using nowadays. They are skipping from all their work. They are becoming lazy and lazy. That's why we don't come to know how to write the structure of the benzodiazepine. What is the composition of the benzodiazepine? We don't know, because not the student mistake, that is the teacher mistake. But in my class it is not like that. Okay, I am showing how to draw benzodiazepine, how we have to be write, everything we'll discuss clearly. Now we'll write the structure of the benzodiazepines. See, the name itself indicate benzo, it have the benzene, diaza, two nitrogens, azepines. Azepine means 7-membered ring. What it is? 7-membered ring, remember, means benzene fused with 7-membered ring, that is called as the benzodiazepine. See, I will write the structure of that. See the structure, benzene. See how I am drawing, just observe it. Just observe how I am drawing this structure. Now see, it is 7-membered or not. We'll count from here. 1, 2, 3, 4, 5, 6, 7. Okay, done. Then see, this is very important part in this case. This is also very important. Here also it have the substitution R1. Here R2. Here R3. Then here R4. We have to give the numbering for this based on the chemical abstract. We are not giving numbering based on the IUPAC. Remember that. Based on what? Chemical abstract. But here IUPAC also it will be work sometimes. Now see, always the heteroatoms have to get the lowest possible number, 1. The next heteroatom will be the next lowest, 2, 3, 4, 5. Then here I am not going to give the number, 6, 7, 8, 9. Then see, now I will be designing this one. This is the ring A, this is the ring B, this is the ring C. For discussing SAR of this benzodiazepine. Okay. See here in this case, diazepam. R1 will be the methyl group, R2 no substitution, R3 no substitution, R4 there is the substitution at the 7th place. R4 means chloro, that is called diazepam. In the same way, oxazepam means here it will be having the OH group. Okay, here no substitution. No substitution means hydrogen will be there. Okay, then here also no substitution, here chloro group is there. That is the difference. Diazepam, here methyl group, but oxazepam, here no methyl group, but here OH group. Like that, the difference you might be see. Now I will be explain the structural activity and relationship, because these benzodiazepines, they are playing the vital role not only in the case of sedative hypnotics, they are very important role they are going to be play in another class also, like anticonvulsants, anti-epileptic agents. In that class also again these benzodiazepines will come. Okay, don't be confused there. Now we are going to discuss about the SAR. What the SAR exactly? What is the relationship between structure and activity? All this will be sedative hypnotic only. This also, like a last class, like a barbiturates, this also going to be depress our central nervous system. It is calm down our central nervous system by binding to the benzodiazepine receptor. Okay, that is going to be release the GABA, gamma amino butyric acid increases, means it causes the depression of the central nervous system. Okay, I hope not only that one, AMPA receptor also, it is prevented that receptor, because that receptor responsible for the increasing, especially this, what it is called for, particularly those receptors will be responsible for stimulation of the central nervous system. That's why we have to be prevent. Now you can see in this case what the SAR exactly means. Now we'll go ring A, B, C. I divided into 3 parts. We'll go for the ring A. In case of ring A, you can see only the one position or 4 position substitution is there. Generally either chloro, either nitro. For example, you can see nitroclonazepam. There is the nitro group here. Observing or not? Nitrazepam also, nitro group will be there. See, in this case, electron withdrawing group. Always remember one thing, you remember, whenever the electron withdrawing group will be present, 99% in the SAR, the activity it is going to be increase. That is the nature of electron withdrawing groups. Blindly you can write that one. 99.9%, that is correct. Means what here? Electron withdrawing group when present in the 7th position, that is R4 place, then the activity, that is sedative and hypnotic activity, it is going to be increases for the benzodiazepine. But when you will be see the 6th, 8th, 9th, these 3 positions, 6, 8, 9, they are going to be decrease the activity or completely abolish the activity. Means no substitution we can do here. कोई भी substitution नहीं करने का. 6th position पे 8th, 9th, only one position or 4, that is 7th position, only electron withdrawing group. If you will be place electron donating group, activity done, no activity, abolish the activity completely. Then next you can see ring B. Very important part in this benzodiazepine. Ring B, always R1 should be the alkyl or any aromatic alkyl, aryl alkyl or alkyl like methyl, always increases the activity. Remember, benzodiazepine activity increases. For example, diazepam, methyl group is there at the R1 position. Okay, activity will be increases. And this observing this ketonic group, oxo group at the 2nd position, that ketonic group is required optimum for this activity, sedative hypnotic activity. Without this you cannot see any benzodiazepine structure. That's why 2nd position keto group very important for the action, for the depression of the central nervous system under what? Sedative and hypnotic. Remember that. Okay. Now we'll go for the 3rd position. This third position, if you substitute any alkyl group or any other group, activity it is going to be decrease. But there, especially at the R2 third position, OH group is playing vital role here in this case. What group? OH group, like oxazepam. Here you can see oxazepam. R2 position, what is there? OH group. Why it is required means OH group is absent means non-polarity increases, duration of action increases. But if OH is present means polarity will be increases, means half-life of this drug will be going to decreases. Sometimes why it will be required this pharmacokinetic property? We might be know it should not be remain long time in our body, because all these are the habitual drugs. We are going to habit for these drugs. If you take more than 2 or 3 pills, Dhamal, we have to be directly, we will be meet the God only. That's why without prescription these drugs also not available in the market. Now see, next here nitrogen will be there. This nitrogen you cannot substitute with any group. If you substitute, decrease the activity, especially at this fourth position. Now fifth position, presence of phenyl ring is very important. Phenyl ring always it will be increases the lipid solubility, always it will be increases the biological activity, because each carbon it will be responsible for the increasing the lipid solubility. Getting my point now? That's why biological activity also increases, because binding affinity with the receptor also increases. That's why the presence of this phenyl ring is very important. All benzodiazepines, you can take alprazolam, clonazepam, nitrazepam, oxazepam, diazepam or any. And another important thing you might be observing between fourth and fifth position, this is very important. If you can this double bond, no, if you change the position of this double bond, just shift this double bond between 3, 4, or here, the activity completely going to be abolished. That's why the double bond should be present always between 4 and 5. Remember this. Double bond position between 4 and 5. You cannot change this. Then another thing here, first and second position. Like alprazolam, one drug is there that is called as the alprazolam here specially. You can be here, make this ring to the specially triazole ring. What type of ring? Triazole form. 1 and second. This also dramatically it is going to be increase the activity, biological activity. This one we can be observed in case of alprazolam, especially first and second position. Now we'll go for the ring C. Ring C is very important here. See, ring C, if you are doing any substitution, especially with the electron withdrawing group, this position is called as ortho, this is the meta, this is the para. Ortho, this is the meta, this is the para. Okay, after this link. This diortho positions also, 2 halogens means 2 electron withdrawing group you can substitute. That will be going to be increase the activity. But meta position, para position, these 2 positions going to be decrease the activity. But at this position, ortho position, disubstitution also increase the activity. I hope you might be understood the SAR of the benzodiazepines, which will be comes under in the sedative and hypnotics, as well as it will be comes under in the anti-epileptic drugs. Thank you very much. In the next class we will meet again. I will share the notes in the Telegram. Link will be there in the description. Please don't forget to subscribe. Okay. See, all the structures I wrote, I shown no. You should have to be respect for that. Please subscribe. Thank you very much. सब्सक्राइब करने से क्या जाता है यार, लोग सब्सक्राइब करने के लिए बहुत सोचते हैं, उससे कुछ भी आपका मेमोरी वो ये फोन का कुछ भी नहीं हो जाएगा। जो भी पसंद आया सब्सक्राइब करो यार। लोग नहीं पसंद आए तो भी करते हैं, लेकिन पसंद आया तो करो, मोटिवेट होता है उससे हमको। थैंक यू।